Hello everybody and welcome to Physics and Astronomy at UTSA. I thought I'd start by orienting you a little bit geographically. This is the Applied Engineering and Technology building, and it is the building that Physics and Astronomy is located in. We occupy the whole of the third floor of this building. Physics and Astronomy has 22 full-time faculty. Of those, 17 are tenured professors, 2 are currently tenure track, and 3 are senior lecturers. We also have 16 adjunct faculty. These are all researchers at the Southwest Research Institute, or SWIRI, and they are space physicists who work on research, but they also advise graduate students doing research with them and teach courses in space physics at the upper division and graduate level. We have about 120 physics majors currently and nearly 80 graduate students. About half of those are doctoral. The department has a whole bunch of world-class researchers across many different fields of physics. I'll get into those fields later. And to do that, we have state-of-the-art labs and computational facilities, many of which are available for undergrads to be able to work in. So let's talk about our Bachelor of Science program. It's 4 years, it's 120 credit hours. Of those 120, 42 credit hours are core curriculum. For all of our major courses and the support courses, so that's basically the math, the chemistry, the computer science, you need to get a grade of C- or above for it to count towards your degree. During your freshman and sophomore years, many of the courses you'll take will be those support courses, so a lot of math, Calc 1, 2, and 3, linear algebra, Diffie-Q, chemistry 1 and 2, plus associated lab, and computer programming. Plus there's a couple of really important basic physics courses, that's physics for scientists and engineers, 1 and 2, and there are associated labs. So that's basically your first couple of years sorted out. Once you've got past those courses, we enter into the gateway courses. You only get 2 goes at this. If you fail a second time, then you're no longer able to be a physics major. The gateway courses are Mathematical Physics 1, Modern Physics and the associated lab, and Classical Mechanics. There are also a bunch of advanced courses that are required. These are Mathematical Physics 2, Electricity and Magnetism, Electrodynamics, Thermal Physics, Modern Optics, Physics Research Lab, Quantum Mechanics 1 and 2, and Unifying Concepts in Physics. Then on top of those required courses, you get the option to take 3 upper division physics electives, and I'll talk about the electives again in a second, and 2 College of Science electives. So here I've got a screenshot of our catalog. This is just the section on electives. So here you can see the range, and it goes from astronomy through computational physics to general relativity to biophotonics to solar energy and so on. You'll notice at the bottom there is special studies in physics. So while this is a list of the courses that are formally available, we also offer special courses that are more specialized on specific topics within physics. You can also do research for credit, and that's the honors research project. In addition to the Bachelor of Science, we also have a Bachelor of Arts and a couple of minors. So we have a minor in physics and a minor in astronomy. Now, the Bachelor of Arts and Bachelor of Science are only slightly different, so I'm not going to go into the difference right now. The minor in physics is not something you're going to do if you're a physics major, so let's talk about the minor in astronomy. The minor in astronomy and astrophysics has 4 required courses. 2 of those are required for the physics major anyway, that's the Physics for Scientists and Engineers. And then there's 2 other courses that are required, Fundamentals of Astronomy and Introduction to Astrophysics. On top of that, you have to take 2 astronomy electives, and we have a list here that you can see. Again, we have special studies, so that allows us to offer special courses, for instance, on exoplanets, or cosmochemistry, or supernovae, or something that we think is, a really cool topic within astronomy. So the courses that are available vary. Now, I mentioned that research is available for undergrads, and that we have amazing research facilities and faculty. As an undergrad, you can do research and get internships. Some internships are paid, some are not. Sometimes you can do research for credit, like a course. And it covers all the different aspects that we do research on in the department. So that's everything from astrophysics and cosmology, to biophysics, to computational physics, condensed matter, nanotechnology and materials, spectroscopy, and microscopy. And so these are all areas that you can go and try out and decide whether it's what you really want to do. Now I want to digress into the sort of careers you might go into after you finish your degree, because it motivates some of the things we do during your degree. If you look at the smaller figure on the left, you'll see that there is a table there that shows you only 4% of physics bachelors are unemployed a year after finishing their degree. About half of the rest are employed and the other half are in graduate studies. Of the ones that are employed, so that 47% that go into jobs outside of grad school, we can see in this pie chart, 2/3 of those will be in the private sector, some will be in college and university, high schools, active military, and government labs. So that gives you a breakdown of the sort of jobs that we have, and the point is that we're trying to prepare you for multiple different possible outcomes and areas that you're going to go into. So we're trying to design our degree and our opportunities for you around giving you as many different skills as possible so you can choose where you go next. Following on from that last slide, if we look at the pie chart on the right, this is for that 2/3 that go into the private sector. It's dominated by engineering and computer information systems, and also other STEM. But you can see that some people go into areas that don't even have any technical problems whatsoever. So again, we're trying to prepare you for all these different possibilities. What sort of salaries do you expect to earn? Well, you can see here, physics is pretty high compared to many other bachelor's degrees. And in fact, for the class of 2018, their starting salaries ranged from just under $50,000 to just under $70,000 a year. Now, as well as giving you research opportunities and preparing you for life once you get your degree, we have student organizations. The Society of Physics Students, Sigma Pi Sigma, is the Society of Physics Students is a national organization. It is we have our own chapter. The Sigma Pi Sigma is its associated honors society, and you can be inducted into that too. We also have an astronomy club. It doesn't have a logo yet, but it works with our Curtis Vaughan Junior Observatory on campus. We do observing. We have open nights for the public. And then we have Rowdy Women in Physics, which is aimed at encouraging women to excel within the area of physics. And you can see here a picture of some of our students doing a Society of Physics student event. All of these societies do a lot of outreach and engagement with the public and community stuff, where they're going out and working with the public on understanding physics. And so there's lots of opportunities to hone your communication skills. Now, important information and contacts that you need to have. Top right, that's a picture of me. I'm the chair of the department. Below me, you can see Dr. Ponce Pedraza. He is the assistant chair. The people on the left are far more important to you. Dr. Rafael Lopez Mobilia, he is the undergraduate advisor of record, that is the UGA. He's the person who'll be doing a lot of advising you on your courses and helping you to choose what you're doing. And then below Rafael, we see Mrs. Belinda Tucker. She is our program manager. She will be your friend. She knows how everything works. And so be nice to her. Now, I want to change direction just briefly and talk about your timing. In about just under 4 years from now, we will have had 2 eclipses over San Antonio. So UTSA is in prime position to view these. So I just want to talk about that briefly. In October 2023, there will be an annular eclipse visible from UTSA. You can see here the path across the US, and there is, and we get to see it on the campus at UTSA. 6 months later, in April 2024, there will be a total solar eclipse, and that is also going to be visible from the UTSA campus. And so you'll be in a position to witness 2 amazing astronomical events and learn all about them, and maybe be involved in research with those too, just because you came here at exactly the right time. I'm just going to finish up by, this is me again, I'm the chair of the department. We also have Twitter and Facebook and Instagram and other social media. Feel free to follow us and tweet, tag us in tweets and all sorts of things. Welcome and good luck.